There is a place in this universe where time stops, where light cannot escape. And it's not science fiction. It's sitting in our own galaxy, right now, waiting. That place is a black hole. And what you're about to hear isn't just spooky trivia, it's some of the strangest, most mind-bending physics ever discovered. Stay to the end, because the last fact will make you question reality itself. A black hole isn't a hole. It's a region where gravity is so extreme, it crushes matter into a single infinitely dense point called a singularity. Around it is the event horizon, the point of no return. Cross it, and not even light, the fastest thing in existence, can climb back out. That means a black hole isn't just powerful. It's a one-way door out of the universe. Here's where it gets wild. In 1915, Albert Einstein published general relativity, his theory of gravity as curved space and time. His equations quietly predicted something monstrous, objects so dense they'd warp space into a bottomless pit. And Einstein hated the idea. He thought it was too extreme to be real, a mathematical ghost, not an actual object in the sky. He was wrong. Spectacularly wrong. And the man who proved it did it from inside an active war. Karl Schwarzschild was a German physicist serving on the Russian front during World War I. While literally calculating artillery trajectories in the trenches, he solved Einstein's equations exactly, and found the precise conditions that create what we now call a black hole. He mailed the solution to Einstein from the battlefield. Weeks later, he was dead, killed by an illness he caught in the war. He never saw his own discovery become one of the most important results in the history of physics. For decades, scientists, including Einstein, treated black holes as a mathematical curiosity, not something real. Then in 2019, humanity captured the first ever photograph of one. An orange ring of light bending around pure darkness, 55 million light-years away. We had proven, with an actual image, something one genius calculated on paper, and another genius refused to believe. Imagine you're in a spaceship, drifting toward a black hole. Here's what actually happens to you. Gravity pulls harder on your feet than your head, because your feet are closer. The difference stretches your entire body like taffy. Scientists call this Spaghettification. That's a real term. From your point of view, you cross the event horizon and feel almost nothing at first, just an ordinary point in space. But to anyone watching from outside, you'd appear to freeze. Frozen forever at the edge, fading redder and dimmer, never actually disappearing. Because near a black hole, time itself slows down. Not metaphorically. Measurably. A clock near the event horizon ticks slower than a clock far away. This isn't theory anymore. GPS satellites have to correct for this exact effect just to keep your maps app accurate. For decades, physicists agreed on one thing: nothing escapes a black hole. Ever. Total prison. No exceptions. Then in 1974, Stephen Hawking dropped a bombshell that broke that rule using quantum physics. He showed that black holes aren't perfectly black. They slowly leak radiation and evaporate over unimaginable spans of time. We now call this Hawking radiation. It meant black holes aren't eternal monsters. They're mortal. Every single one, no matter how massive, will eventually die. Hawking spent the rest of his career obsessed with the strange paradox this created, one that even he couldn't fully solve. Here's the problem. When something falls into a black hole, all its information, its exact atomic structure, should be gone forever. But quantum physics has an unbreakable law. Information can never truly be destroyed, anywhere, ever. So which law breaks? Gravity's or quantum mechanics? Nobody has fully answered this. It's called the black hole information paradox, and it's one of the biggest open problems in all of physics. Some of the smartest minds alive, including Hawking himself, spent decades arguing about it, sometimes publicly betting against each other. In 2020, mathematician and physicist Roger Penrose won the Nobel Prize in Physics for proving something chilling. Using pure mathematics, Penrose showed that black holes aren't a rare cosmic accident, they're an inevitable consequence of general relativity itself. In other words, given how gravity actually works, the universe was always going to build these things. They aren't a bug. They're baked into the rules of reality. At the center of our own Milky Way galaxy sits a black hole called Sagittarius A, with a mass over 4 million times that of our Sun. Every star you've ever seen, every planet, every person who has ever lived, we are all slowly orbiting that monster right now, as you listen to this. Some black holes are so massive they're almost impossible to comprehend. TON 618, one of the largest known, has a mass over 60 billion suns. If you replaced our Sun with TON 618, its event horizon would swallow our entire solar system whole, and reach halfway to the next star system. Some physicists, building on Einstein's equations, have proposed that the extreme centers of black holes could theoretically connect to wormholes, shortcuts through space-time to somewhere else in the universe, or even another universe entirely. This isn't confirmed. Nobody has seen one. But the math doesn't rule it out, and that alone has kept theoretical physicists up at night for generations. Here's the part most people miss. Every black hole in existence came from something that used to shine, a star that lived, burned for millions of years, and collapsed. Which means the darkest, most feared objects in the universe are actually graveyards of light. Echoes of stars that once looked a lot like our own Sun. And one day, unfathomably far in the future, after every star has burned out, after galaxies have drifted apart, black holes will be some of the last things left in the universe, slowly evaporating into nothing. Stephen Hawking spent his life studying objects that swallow light, time, and even information itself, objects most people are simply afraid of. But here's the real takeaway. The universe's scariest objects are also its most honest teachers. There where gravity, time, and quantum physics all collide, and force us to admit how much we still don't understand. If you're near a black hole and look toward it, you wouldn't just see darkness. You'd see the entire universe, every star, every galaxy, smeared and warped around it, like the black hole is showing you all of existence at once before it takes you in. That image, the whole universe wrapped around a single point of nothing, is the last thing physicists agree is genuinely, provably real.